let's see if I can get us lined out on some examples that we talked about today. What we talked about today, sort of applying our Solow model to the current crisis. And so I think what we looked at was a decrease in the amount of labor, a decrease in human capital, and a decrease in the savings rate or the investment rate. So those are sort of the three things we could look at. Now let's take a look. If we go to our base model, we have capital and output. Now we know because of our assumption of diminishing marginal returns that we need an alpha between 0 and 1, which will result in our function looking like that. I'm going to go ahead and dump in technology in here so that we know what this is doing. So if we take a look at labor, what would happen? Arguably, we can set this up in a more simplified, in a more straightforward version by looking at capital per labor and output per labor, in other words, putting these in per capita terms. But short of reworking our model, just sticking with what we have, let's think about what would happen if we have less labor. So let's just pick this number of machines right here. Let's say we have that number right there, K prime. What that's going to mean is, absent anything else, we would have that amount of output. So as we decrease labor while holding machines constant, what would happen? Well, I think it's fairly reasonable. This might break our model a little bit, but we'll get some insight out of it, I think. So would be to think about if we have fewer workers for the same number of machines, each machine would be less productive. Maybe something like that, y prime, not y to the first, there we go. So I think that would be a reasonable expectation of what would happen with our reduction in labor. Now, before we move on, let me see. So what would initially happen would be a reduction in output. Is that what we're seeing? Yeah, sounds about right. As we have fewer people working as a share of the population, or just in raw numbers, we have a reduction in our output function and a reduction in output. Now let's see if we can think about what happens next. So before, this was our investment line, which was a function of this. It was a certain percentage. Now that this line has shifted down, that line must shift down. And by the same token, we think about our depreciation function. Depreciation was just a certain percentage of machines break down. Has that percentage changed? I would argue that it has not. And so the initial reaction is going to be a reduction in output, and before we were going to be growing in a positive fashion, and now as I've drawn this just by happenstance, there's no reason these cross here, but now by happenstance, so previously we were going to have this many machines added, we were going to have this many machines breaking down, which meant we were going to be adding that many machines, and next year we would have been here. However, instead of being there, now as I've drawn this, investment and depreciation will be the same, which means we will stay right here. So we would have a decrease in the growth rate as well. Now some of you might say, well, but isn't that just dependent on being right here? Well, let's say that instead of being right here, we were maybe we would say, okay, let's say we were way back here, okay? In which case, this would have been our level of output before the change. This would have been our new output, so that would fit as well. Before, we were going to add this many machines, thus ending up out here and growing from here to here, and now instead of that, we will be just growing a small amount. This would be how many machines we add, this will be how many we break down, and so next year we're going to go here. Now this gets a little bit tricky to see because we're talking in percent change terms here, but I think most of us would understand that this as a percentage of this is probably a smaller amount than this as a percent of that, although that might be not fully clear. But this is, again, how we can start to look at this. Okay, so let me clean this up. That is our decrease in labor. And again, this isn't about right answers. Other people might approach this in a slightly different fashion, or they might map this onto different areas, which is fine. We can, again, tell that story. So now let me just change tacks a little. I didn't do this in the slides, but now let's hold everything else constant and look at the relationship between human capital and output. So we're going to hold labor constant, we're going to hold capital constant, we're going to hold technology constant, we're going to hold organizational structure constant. And by implication, we're also going to hold, and we're going to hold the savings rate constant, the depreciation rate constant, etc. And by extension, we're going to hold institutions constant. So let me look at the relationship here. I'm going to argue that we are going to have the same, a same function here. In other words, if we hold everything else constant, there's almost certainly going to be diminishing returns to human capital. And there's almost certainly an investment rate for human capital, and there's a depreciation rate for human capital, which yields an investment and a depreciation function, just like we have before. So let's just pick a spot and say we were right here, in which case this was our level of output. Now, if because people die or because they're laid off, we're using less human capital while holding everything else the same, that would be moving in this direction, just basically exogenously decreasing or destroying our human capital. That would cause a reduction in output. And now the question would be, what happens to growth? So in other words, this would be a reduction in the level of production, and then the question is, what happens to our long-term trend with time? So before, this was our level of human capital before. This was our number of units of human capital that we were adding. This is the number that we're breaking down. And so we would be going from here to here before, which means we would be going to here. So this divided by this would give us our percent change. Now what's happening? Now we are adding more machines than we would have before. Well, this gap is bigger rather. And so we would be going to here next. And it turns out this is going to be a larger amount as a share of a smaller amount. So if you increase the numerator in your percentage and you decrease the denominator, the whole thing will increase. So again, this would cause us to be worse off, but would increase growth in our model, right? This would mean that we are worse off in the short run and almost certainly worse off in the long run, but our growth rate would go up. That may be a little counterintuitive, but again, that's why we have a model. So again, I broke some of the things of the model that we've talked about so far, but if you understand the underlying model, you can do it, you can extend it out to here. So far we've had two things. Both of these cause a decrease in output, and both of them cause, but they have different signs on their impact on percent change. Now let's look at savings. And again, just like with supply and demand, you can look at these individually. You can also look at them together. But again, I would encourage you to start looking at them one at a time, and then if you need to put them together, you could combine them. So, the impact of a reduction in the savings rate on its own. What would that do? Well, we've been assuming that all savings makes it directly into investment. And so savings, this is our savings rate right here, or our investment rate. Again, we're going to relax the assumption that all savings makes it into investment. It is entirely possible as a result of the current crisis that the savings rate goes up. In other words, people save more money. However, as we're going to talk about after the exam, they're going to be probably in the current environment less willing to send it across the bridge to people who want to use it to add new capital here. Right? People are going to stick it under their mattress. They're going to stick it might hold it in the bank account, but the banks lending out in this environment? So let's either think about a reduction in the savings rate or possibly an increase in the savings rate but a decrease in our investment rate. So what would that do? Either that or is going to cause this to happen. In other words, 20% of the same amount or a smaller percent of the same amount is going to be a smaller amount. And then the answer, well, let's think about what's going to happen. Let's say we were here before. If we had this much capital, and that's all this is this gives us, just like with supply and demand, it gives us the ability to look up two things. Same thing here. We can look up capital and other things on this chart. So beforehand, we would have had that output, and this would have been the number of machines we added. This would have been the number of machines that broke down. So next year, we would have had this number of machines here, which would have meant that output would go up. Now, we're still going to have this output because we have the machines that we have. We're just changing how many we're going to add for next year. And now as I've drawn this is the number that break down. This is the number that are replaced. And so now we are actually going to contract. So rather than a positive growth rate, we're going to have a negative growth rate. Turns out if we do that anywhere along in here, and maybe I should do that. Let's go ahead and do that. So that would cause no change in output, but a reduction in the percent change or the growth rate in output. Let me just clean this up and ponder. So that was at that point right here. Now let's see if I can clean this up well enough to look at what would happen if instead of being right there, we had been right here. Well, if we'd been right here, that would have been our output. And what's going to happen now? Same output. There would be no impact on output because we have the number of machines that we have. Last year, this was the number of machines that were being replaced. This is the number that we're breaking down. In other words, we were going to move out to here, thus having that much output. So this distance divided by this distance would be our growth rate. Now, this is the number of machines that are replaced. This is the number that break down. And so next year we would just have that many, which would cause us, instead of growing to here, we would grow to here. So again, no change in output, a reduction in our growth rate. And now we'll just do another one, maybe way the heck out here. Let's say before this was our amount of capital. That would mean this would be our output. And what happens when we reduce the savings rate or the investment rate? Nothing to output. This is our amount of output that we have. However, next year, instead of adding this many new machines, we're only going to add that many new machines. So previously, this was the number that break down. This was the number that we add. And so we were going to shrink by that much, which was going to cause a reduction in growth to here. Now what's going to happen? This gap just got a lot bigger. So this was the number that we add. This is the number that break down. So this many we're going to lose that on net. And so instead of decreasing by this amount, we're going to decrease by this amount, by a larger amount. So our denominator would stay the same and our numerator would get larger. And so again, we would be here. So there's 3 examples of how we can play with this. Again, I think that that's really where this model starts to shine. Some of you are going to be frustrated because you're sitting here saying, I still don't know what the right answer is. We're back in the realm of where we spent the time with supply and demand. it's frustrating when you first start, but if you think about where most of you are at this point, and I think actually everybody in the class is at this point, you are able to harness the tools of our supply and demand model to tell better stories. We may disagree over whether something's a normal good or not. Same thing here. We might disagree whether the savings rate is going to yield, right? Whether the savings rate is going up or down, and whether that's translating into an increase or a decrease in the investment rate. These are all reasonable discussions that we can have. But again, this tool is meant to provide us with a framework within which we can have those discussions. So hopefully that helps. Let me know if there are other things you would like to see mapped on here, and I can try and record some short videos with the application of the tool here.